Aloha and welcome to our video on early astronomy. In this video, we'll describe the contributions of the ancient Greeks. We'll also talk about Copernicus, Brahe, Kepler, Galileo, and Newton. Okay, so let's take a quick peek at some of the contributions to astronomy by the ancient Greeks. Now, first on our list, we have Aristotle, and Aristotle is probably one of the greatest thinkers of all times. However, because of this, sometimes his ideas lasted longer than they should have. He believed in perfect spheres. He thought that the sphere was the perfect shape. So therefore, the Earth would have been a perfect sphere, space would have been a perfect sphere, all of the planets would have been a perfect sphere, and they were perfect. There were no imperfections on them. And this idea kind of stuck and was held around until we see about what Galileo started to discover. Now, Aristophanes, we see here, he factored out the size of the Earth, and he factored the size knowing that its shape. So the ancient Greeks had a really good understanding that the Earth was round, and we can see how Aristophanes calculated the Earth's circumference here. And what he did is he measured, by looking at a well, this angle, and he found an angle to be 7 degrees here. And that angle that he found was based on a well from or a post in Alexandria and a well at Sion, and he was able to see the difference in the sun. That gave him his angle there, and then by calculating how far those two cities were, he was able to calculate the Earth's circumference, and he was pretty close. So a really good mathematical way for him to solve this. Aristarchus is credited with proposing a heliocentric model, and that was kind of against the norm. Man has always considered himself to be special, so we would be the center of the universe because we're the most special thing there. But Aristarchus proposed a heliocentric model. And he looked at stars and the idea of parallax, but unfortunately, all he had was the naked eye. He didn't have telescopes, so his observations weren't able to show that this parallax does indeed occur. And then we talk about Ptolemy. And Ptolemy predicted planetary motion, and we'll talk a little bit more about his in the next slides or so. But he was able to come up with a system of predicting these planets, how these planets moved. Now, the ancient Greeks called these planets because they were wanderers in the sky. So you had your stars, which were more stationary, and then you had these other ones that were moving, and those were the planets. We also have to mention Hipparchus. Hipparchus cataloged about 500 stars that he could see with his naked eye, and we still use his star catalog today. So he proposed a whole bunch of other things, probably the greatest of the Greek astronomers, and if you ever have the chance to look into what he's done, that's a really good person to look into. So some terms that you're going to hear a lot as we're talking about astronomy are geocentric and heliocentric. Geocentric, geo would be Earth, so what we're talking there is we're talking that the Earth was the center of the universe. Around the Earth we would have the moon, around that we would have Venus, and then we would have Mercury maybe, and then we'd have the sun, and then we'd have Mars, and so forth, and out here we'd have the stars. But the key thing with geocentric is that the Earth was in the center. Now, in contrast to that, we have a heliocentric idea, and a heliocentric idea puts the sun in the middle of this. So around the sun we would have Mercury, and then Venus, and the Earth, and then Mars, and so on and so forth. So two different models, you'll hear about this a lot in the lessons. We have heliocentric, meaning the sun's in the middle, and then we have geocentric, which puts the Earth in the middle. Now, we discussed Ptolemy a little bit earlier. We said that he worked with planetary motion. So what he was able to do is he was able to predict where we would find these planets. And what he did is he created up these different systems. Now, remember we talked about Aristotle and we talked about perfect circles. So what they believed is that we had the center of our solar system, whether it was the sun or the earth, and then around that in perfect circles is where you would see these planets. Everything was in a perfect circle orbit like so. Now, this worked out well, and you could see how this would work, except we would notice, and if you see here on number 1, right up here, what we're talking about is we're looking at Mars, and we're looking at the background stars. So what we're seeing in this motion is as we're going, we're going to notice that Mars as a planet against the background stars is going to be moving in this direction. Now it gets to a certain point, and we notice that suddenly it's going in the opposite direction, and we call that retrograde motion. So this here is where we call retrograde motion, where it seems to be moving backwards. And it would do that for a certain point, and then it would resume this normal motion again. So in order to work that ways through, Ptolemy came up with the idea of epicycles. So while you might have a perfectly circular orbit, that planet might be on another circle here, and that would be an epicircle. And then this could have another circle here, and then you could have another circle, and you'd have so many of these epicircles until you could explain all of the motions of the planet. So not a perfect system, but it was highly accurate, and that's why it stuck around for so many years. Now, if we jump into the 1500s, we have two astronomers I want to talk about real quickly on this slide. The first one is Nicholas Copernicus. Now, Copernicus was the first of the more modern astronomers. So we gotten out of the ancient Greek, and not a whole lot of astronomy was going on, and the reason for that is the powers that be believed what Aristotle said, so his ideas seemed to be carried on. So everything was a perfect sphere. We had perfectly spherical orbitals. We could use these epicycles of Ptolemy to predict the planets, so we didn't see a lot of new thought. Copernicus went back and he proposed this universe here. And I kind of want to show you that he went back to a heliocentric. So that means he put the sun here in the middle. And around the sun, you can see that he had the Mercury sphere, the Venus sphere, the Earth sphere. And then around Earth, notice he has another sphere, and this is where we found the moon. Then beyond that, we had Mars and Jupiter and then Saturn. And that's as far as we went. Those were the only planets we knew. And then beyond that, we had the stars. So we had this realm of stars that was the farthest out there. So no knowledge of distance, it was just the outermost edge that we could see was this ring of stars. And while Copernicus's idea wasn't exactly new, it made sense. It got away with some of the epicycle ideas, and it allowed it to be a little bit simpler, and scientists agreed with it, but we didn't have the really good evidence of it. And that brings us to another scientist, Tycho Brahe. And what Tycho did is he was kind of a partier. He liked to have a good time, and he had his own observatory. And for about 20 years, he would go out every night and he would record where the stars were. But he was more interested in his social life than actually doing a lot of stuff. So what he did is he would basically surround himself with great scientists. But he did for 20 years went out and he made detailed observations of where the planets were, where the stars were, and things of that nature. So when Tycho died in 1601, his estate was left to one of these scientists that came to stay with him. And this scientist was Kepler. Now, Kepler was a mathematician by trade, but he was fascinated by the stars. And what he did is he looked at Tycho Brahe's work, and having 20 years of data gave him the ability to look and to see what was going on in the universe and in the solar system around us. And he came up with his 3 laws of planetary motion. The first one is the law of ellipses. And this contrasted with what Aristotle said, but rather than these planets traveling in a perfect circle, they were traveling in an ellipse. And that's a slightly difference. Now, the ellipse might not be great and pronounced, but it was an ellipse nonetheless. And once we switched the shape, then all of a sudden we could get rid of epicycles because everything started to seem to make shape or make sense. Now, the second law is what we call the law of equal areas. And what that says is that in a certain amount of time, a planet's going to move in orbit. The area from the orbital radius to the sun, this little triangle that we have here, and I'll color it in red so you can see what we're talking about, this one here is going to have the same area as any other wedge that we would cut out of that ellipse that passes for the same amount of time. So what that detailed is that our planet seems to move a little bit slower when they're out here, and they seem to move a little bit faster here, and it's the area that's the same, it's not the same distance. And then the third law was kind of interesting. His third law here basically gets summed by this one here. And what it says is that the square of the orbital period is directly proportional to the cube of the semi-major axis. And what that allowed us to do is predict how long it would take for a planet to go around the sun if we knew how far away it was, or if we knew how long it took to go around, we could calculate how far it was. So that helped us finalize the distances and the periods for our planets in the solar system. So Kepler did a lot of math. He kind of corrected our ideas of the orbital shape. Instead of it being a circle, we went to an ellipse. And this brings us to Galileo. Now, Galileo was an interesting scientist. He was very firm in his convictions. He stuck with his ideas. He didn't want to change them. He didn't want to bend them to fit into popular culture or to the governing powers that be, but instead he kept true to his beliefs and his ideas. What made his observations unique was he heard of this thing called a telescope, and then he worked on it and made it a little bit better. And he used his telescope to make observations. And the observations he made were kind of like not so profound if we look at what we know now, but at the time they shook the world. One of the first ones that he found is he looked at Jupiter with his telescope and he noticed that Jupiter had 4 moons, and these are the Galilean moons. And we'll talk about those when we talk about the solar system a little bit later on. But he noticed that here we have another planet that has moons orbiting around them. Now, up until this time, we had a lot of belief that we were a geocentric. Remember, we said that man is the most important thing in the universe, so obviously we have to be in the center. Well, if we have moons orbiting another planet, now suddenly we're not the center of everything. So that kind of really shook a lot of people's idea of man, because now we were saying we weren't the center of the universe. He noticed that the planets were disks and not simply points of light like the stars. He looked at Venus and he found that Venus had phases like the moon. And the only way to explain this was not that Venus was traveling around us, but it would be traveling around the sun. So now we had conclusive proof that we had a heliocentric universe. The next two also were kind of disturbing, and these went against Aristotle's ideas. Now remember, Aristotle believed in the perfect sphere. So when Galileo turned his telescope to the moon, he found that it was not smooth. You would expect the sphere to be perfectly smooth, but it wasn't. It was impacted with craters, it had scars and things like that on it, so it wasn't a perfect sphere. Now, this contrasted Aristotle's thought, and remember that Aristotle was thought to be the greatest thinker, so his ideas had to be true. Now we were casting doubt into the whole ideas of Aristotle, and that transcended beyond astronomy. And the last were sunspots. And Galileo would look through his telescope at the sun, so not a very good thing, so he probably had pretty poor vision when he got older. But when he noticed that the sun itself wasn't perfect, and this was really shattering. The moon is kind of bad, but now to say the sun, the most perfect thing that we know of, the brightest thing in our sky, wasn't perfect. And that's what Galileo kind of shot out at us, is he showed us it was a heliocentric model, kind of took away the importance of man, and showed that the universe isn't perfect like Aristotle believed it was. So really some profound ideas that changed a lot of human thought came from Galileo. And this brings us to Sir Isaac Newton. Now, Sir Isaac Newton's famous for gravity, and he found out that gravity alone could be what caused the planets to move around the sun. And that was his idea of universal gravitation. And the lessons will explain that a little bit more. He also started playing around a little bit more with telescopes and working with mirrors and things like that. So he had a much better telescope than Galileo did, but still it was not as advanced as the ones that we can get now. Okay, so those are our early astronomers and their ideas that they put forth. As always, good luck on your quiz, and we will see you in the next video.